Hello, welcome back to the next session. And in this video, we are going to talk about the next variety of a chemical reaction, that is double displacement reaction. Okay, you all got to know what was displacement reaction. Displacing in the sense what? More reactive element will occupy the position of less reactive element in a solution. Okay, and here double displacement reaction. So look at the definition. The reaction in which exchange of ions are groups, anything you can call, exchange of ions between the reactants takes place. You will observe the exchange of ions, exchange between two groups you will observe. Okay, such a reaction is called double displacement reaction. Okay, so whenever you write a reaction, you will take two reactants, no? So something is getting exchanged between the two reactants. So such a thing if happens in a reaction, then such reactions are called double displacement reaction. Okay. During double displacement reaction, one unusual thing will happen. Product will appear as white color insoluble solid. Okay, that insoluble means what? Not dissolving in water, not getting a clear solution. Okay, if the solution is not clear, if you are getting some solid particles, colored particles as the solid, then such a colored particles that you are getting, no, that is called precipitate. Okay, so an insoluble substance that is formed during double displacement reaction is called precipitate. Okay, so these reactions are also called precipitation reaction. Okay, you have another name for displacement reaction, that is nothing but precipitation reaction. Clear now? So what is a displacement reaction? The reaction in which exchange of some ions takes place between the reactants. Definitely you will take two reactants here and some groups are getting exchanged between them. So such a thing if happens in a reaction, we call it as double displacement reaction. And product is obtained as a precipitate. Two products you will observe here. I will show the example. Among the two products, one of the product will be colored solid and that solid will not be soluble in a water. It will not go into a solution. You don't get a clear solution. So such a product which is formed as a colored substance, not clear, not soluble in water, is called as precipitate. Since precipitate is forming in a reaction, we also call these reactions as precipitation reaction. Fine. Let us see one example. Very important example it is. Example 1. So whenever sodium sulfate is added to barium chloride, how do you write the formula of sodium sulfate? I thought you to write the chemical formula. Yes or no? So sodium sulfate, Na, sodium sulfate is a polyatomic group. Okay, Na valency 1, sulfate valency 2. So this one you will write here, this 2 you will write there. So what will be the formula of sodium sulfate? Na2SO4. This is what? Sodium sulfate. Sodium sulfate. So I am adding this to barium chloride. BaCl2. Barium chloride in the sense Cl. Barium valency 2. Chlorine valency 1. So barium chloride formula is BaCl2. So what is its name? Barium chloride. And both are colorless liquids. They just look like water. They just look like water. See, I took water like substance in this. This is called barium chloride. This is called barium chloride. And sodium sulfate is also looks like this only, just like water. Barium chloride also looks like water. Sodium sulfate also looks like water. And both of them when I combine, imagine this is a barium chloride. In another test tube I took a sodium sulfate, that is also looking like a water. When I added both of them together, you know, surprisingly, I will get a product like this. Can you observe this? How does it look like? Is it clear like water? Is this clear like water? No, no. It is some white color insoluble substance. This white color insoluble substance is what we will call it as precipitate. Fine. So what happens here is when I add this to this, sodium comes in the position of barium, barium goes in the position of sodium. See, exchange of ions or elements is taking place. Yes or no? What will happen? Barium will go in the position of sodium and sodium will go in the position of barium. So if that happens, tell me what is the product you will get? You will get, see, barium is going in the position of sodium. So you will get barium sulfate. Is the barium sulfate formula correct? You will not get Ba2SO4. Since Na2 is there, barium if it goes here, Ba2 you don't get. Check the formula with the help of valency. Barium valency 2, sulfate valency 2. This 2 you will write here, this 2 you will write. When the digit is same, it will get cancelled, no? So you will get barium sulfate. Plus what else you will get? This sodium will come in the place of barium, right? So you will be getting NaCl. You will be getting NaCl. Okay, Na valency 1, Cl valency 1, so NaCl. Since barium chloride BaCl2 is there, sodium comes in the place of barium, so you will get NaCl2. Concept is not like that. So formulas you have to write according to the valency only, always, whenever you write a chemical equation. And now balance the reaction. Reaction is not balanced. Here 2 sodiums are there, no? So you will be putting 2 here. And that's it. Now the reaction is balanced. 2 sodiums, you have put 2 sodiums. 1 SO4, 1 SO4. 1 barium, 1 barium. 2 Cl, this 2 can belong to Cl also. So 2 Cl. Clear? Got to know? So when I added the colorless liquids, see the product what I got. I am not getting a clear product. I am getting some solid thing which is remaining insoluble in water. Okay, it is not soluble in water. How much ever water you add, say to this again I will add water. It is not soluble, it is not going into the water. It is remaining as colored substance only. So such a colored substance is what we call it as precipitate. Since, say here, which is coming as precipitate? Barium sulfate is coming as white color precipitate. Okay, PPT means precipitate. Okay, PPT in the sense what? Precipitate. In shortcut, we will write precipitate as PPT. So, one of the product, that is barium sulfate, whatever has formed, no, that is what we will get. Remaining sodium chloride will be there in a solution as usual, colorless. Here barium sulfate, white color is dominating. So, the whole thing is looking like a white color solution. Clear everyone? So, this is what we call double displacement reaction. This only we will call double displacement reaction. Why do we call it as double displacement reaction? Because here exchange of ions or elements is taking place between the reactants. So you are getting a product and one of the product will appear as precipitate. some colored substance. Okay. And one more example we have. This is also a very famous example, and exam point of view, this is very much important. So what is that example? I have already discussed this example in the previous videos. It is not a new reaction. Say when lead nitrate, you all know the lead nitrate formula, yes or no? This is lead nitrate, is added to potassium iodide. Okay, both are colorless actually. Lead nitrate is also colorless, potassium iodide is also colorless only. You will get, what happens, lead goes in the position of potassium, potassium goes in the position of lead. First element only, first elements, first whatever elements you write in a formula, no, those will get exchanged. So lead will get exchanged with potassium. If potassium goes here, lead comes here, what is the substance you will get as a product? Lead, Pb, see lead is coming in the position of potassium. So Pbi, is the formula correct? Check with the help of valency. I gave you lead valency 2, iodine valency 1. So what is the formula? Pbi2, no? This 2 we will write here, this 1 here. So this is the formula of Pbi2. And what is the other substance you will get? Potassium is going in the place of lead. So you will get KNO3. Formula correct? Potassium valency 1, nitrate valency also 1. So formula is correct. Now you have to balance the equation. How do you balance? 1 lead, nitrate 2 is there, here 1 is there. So you are putting 2 here. Okay. And now it became 2 potassium, here you are putting 2. So 2 iodine, 1 lead. Balancing, I thought you were trick, no? You should apply that. And here, this is also colorless liquid just like water. This is also colorless liquid just like water. But lead iodide, whatever you are getting here is yellow precipitate. Okay. So in the previous case, barium sulfate is white in color just like this. Similarly, yellow colored precipitate you will observe in this reaction. And what is that yellow colored precipitate? Lead iodide is yellow colored precipitate. So definitely in double displacement reaction, one or the other precipitate, colored precipitate is formed. In different reaction, different colored precipitate is formed. So this is about double displacement reaction. And now we will go for oxidation reaction. Coming to the next type of a reaction, that is our oxidation reaction, and the other one is reduction reaction. Okay, both are little just opposite to each other. Just like combination and decomposition, how they were opposite to each other, no? Similarly, oxidation and reduction, both are opposite to each other. Their meanings are exactly opposite. Okay, fine. And first and foremost, coming to the oxidation reaction. I have written the definition here, just try to read it. Addition of oxygen or removal of hydrogen is called oxidation reaction. Okay, say you have a particular chemical reaction. Looking at the reaction, you can come to know what element is added to what element is being removed and all, right? So you have to observe that. In case if you find oxygen is added or if you find hydrogen is removed, how do you know that which is removed? If you compare with the product, you will come to know. You have to compare between reactant and product. Then you will come to know what is added, what is removed. Okay, that thing you have to observe in a reaction. And if you observe, in any case, if oxygen is added or hydrogen is removed in a particular reaction, then such a reaction is called oxidation reaction. When I give you the example, you will understand better. Okay, fine. And here to explain the example for this reaction, I will do some experiment, not live experiment, just I will show a figure on a board, try to understand. Okay, I am taking a copper in some vessel. This is a vessel. I took a copper. What is the color of copper? What is the color of copper? Copper will be there in a brown color. You see, we have done an experiment, no, displacement reaction experiment when we did on the iron nail. After the reaction, copper will deposit, I said. See this brown color thing that is there on this iron nail. You know, copper will be there in this color, brown color. This is what copper, this brown color thing. Fine. And copper which is there, a brown solid, which is nothing but our copper, symbol Cu. Okay. And I am heating this copper. Say, I have a Bunsen burner. I told you Bunsen burner is the instrument we will use to generate a flame. Okay. So, this is a flame. So, as I start giving a flame to the brown colored copper, this brown colored copper will get converted into black color substance. Okay, so that black substance is called copper oxide. Okay, so as I start heating this brown color copper, this brown color copper will be converted into black color substance, which we call it as copper oxide. Okay, so how do you write the reaction? I took brown color copper. Okay, I took a copper which was there in brown color. Okay, and I heated it. I told you, whenever you burn something, whenever you heat something in an open air, okay, the element or the substance, whatever you have taken, whatever you are heating, no, that will react with oxygen. Okay, I no need to tell it will react with oxygen. You have to understand. I am burning this particular copper in the open atmosphere. No, I didn't close the vessel at all. Okay, I kept it in the atmosphere and I am burning. So automatically it should come to your mind that burning is nothing but reaction with oxygen. Just like Mg ribbon, we kept it in a flame. I told it will burn. What was the reaction you wrote? Mg reacted with oxygen, no? Yes or no? So here also same thing. That brown color copper, I took it in a vessel. I started heating it. So copper will burn in the open atmosphere, means copper is reacting with oxygen. Okay. So combine both of them, you will get copper oxide. Okay, what do you get? Copper oxide. Is that clear? Copper valency is +2, oxygen valency is -2. 2. This 2 goes here, this 2 goes here. When the digit is same, we will cancel off the digits, no? So copper oxide. You no need to by head the formula, children. For every formula, you can use that valency concept to write. Clear? Fine. So, what has happened here? Oxygen is added to copper. What you have observed in this reaction? Addition of oxygen is observed. So, this reaction I can call it as oxidation reaction. This reaction we can call it as oxidation reaction. Okay. So, what are the other examples that you can give for oxidation reaction? Say this one you should know, particularly in this reaction. Color changes and all you should observe. So based on the colors of a particular reaction also they'll ask you a question in the exam. Okay. So here your brown color copper has converted into black color copper oxide. Black color copper oxide. Okay. This is called copper oxide. So this is called oxidation reaction. So what are the other examples that you can give? What other examples that you can give? I will rub this diagram. You have learned so many reactions so far, no, during balancing and all. So among them, can you list out any reactions under oxidation category? This is example 1. Example 2. Mg ribbon, Mg burning. I told burning in the sense reaction with oxygen. What do you get? MgO you will get. Yes or no? So here also it's like oxygen is added, right? Reactant side you must observe. Whenever you see oxygen is getting added to some substance, then such reactions, all of them can be called as oxidation reaction. Is that clear? Or removal of hydrogen is also oxidation reaction only. In any reaction, if you observe hydrogen is being removed, then also such a reaction is called oxidation. Anyway, regarding to that, I will give the example later. As of now, try to remember these two. Addition of oxygen is always oxidation. Not only addition, whenever you find removal of hydrogen, then also you can consider it as oxidation. And coming to the reduction reaction. Reduction is just opposite. Just opposite. See, compare the definitions. Addition of hydrogen, okay, or removal of oxygen is called reduction. What was oxidation? Addition of oxygen. What is reduction? Addition of hydrogen. And what you can remove? Oxygen you can remove here. There, what element can be removed? Hydrogen can be removed. Okay. What element is added? Oxygen is added. Here, what element is added? Hydrogen is added. What element is removed? Oxygen is removed. Okay. You should not get confused with the definition, guys. It's very important. Just try to compare the definition. Sit for 1 minute silently. Observe the definition. Analyze and then remember with the examples. Okay. So, just both of them are opposite to each other. Here, addition of oxygen is called oxidation. Addition of hydrogen is called reduction. Not only addition of hydrogen, removal of oxygen is also called as reduction. Okay, fine. What example that you can give? Say I am taking sodium is the element and I am adding hydrogen. Say this hydrogen, you cannot write single H. Hydrogen is not present as single H in our nature. It is always present as a molecule, H2. Similarly, oxygen also. There are certain elements which are not present as single atoms. They are always present as molecules. Okay, oxygen is present as O2. Hydrogen is present as H2. Nitrogen is present as N2. Chlorine is present as Cl2. Like that, few elements are present as gases in the form of molecules in the nature. So, I am adding hydrogen to a sodium. I will get a product NaH. Sodium hydride. We will call this product as sodium hydride. How do you balance this equation? Every equation that you are writing in your notebook has to be balanced. Even if I don't balance it here, if I forget balancing here, in your notebook, you should analyze and balance the equation. And whatever is written on a board, you should note it down in your book compulsorily. Fine. And how do you balance this? 1 Na, 2 hydrogens, no? So you will put 2. Now this 2 belongs to sodium also. So sodium is only 1 here, you are putting 2 there. And how do you balance here? Copper 1, okay. Oxygen 2, here only 1, so you are putting 2. Now copper has become 2 this side. This side you have only 1, so you are putting 2. Mg, similarly. The balanced equations are compulsorily to mention. Fine. So, got to know the concept, main concept. Oxidation means addition of oxygen to a substance. Reduction means addition of hydrogen to a substance. But they have another meanings also. Oxidation means not only addition of oxygen but also removal of hydrogen. Reduction means not only addition of hydrogen but also removal of oxygen. Okay. So these second meanings, we will discuss now. We will discuss in a special type of reactions called redox reaction. So we are going for the last type of a reaction called redox reaction. So redox, see the name to pronounce itself is different. But you see, redox means, RED means reduction, OX in the sense oxidation. Okay, the reaction where you will observe both oxidation and reduction is called redox reaction. So what is the definition that you can give here? Reaction in which both oxidation and reduction can be observed. Such reactions are called redox reaction. Okay, single reaction you will observe oxidation also, reduction also. What is oxidation? Addition of oxygen or removal of hydrogen. What is reduction? Addition of hydrogen or removal of oxygen. Okay, so both the processes you will observe. Oxidation also you will observe, reduction also you will observe. Such a reaction we will call it as redox reaction. Now let us speak about the example here. Say I am taking a copper oxide. Okay, I am adding hydrogen to it, and the product I will get here is copper plus H2O. Copper plus H2O. Okay, balance the equation. 1 copper, first you see whether it is balanced or not. 1 copper, 2 hydrogens, 2 hydrogen, 1 oxygen, 1 oxygen. Okay, reaction is already balanced, so you no need to touch the equation. Fine. And observe here. See here, copper oxide has converted into copper, right? Copper is our main element. Here copper is there as copper oxide in the reactant side, and this particular guy has converted into copper. So what you will observe in this process? Copper oxide became copper. That means removal of oxygen is observed. What is observed here? Removal of oxygen is observed. Removal of oxygen is called reduction. Yes or no? Removal of oxygen. What do you call it as? Removal of oxygen is called reduction. So this process I will call it as reduction. This is how you have to observe whether it is a reduction or oxidation. Okay, see, copper oxide is becoming copper. What you have observed? Oxygen missing you observed. Yes, oxygen removal you observed. So removal of oxygen is called reduction. So I have written this process as reduction. Okay, and now you see the other element. 2 reactants you have. Among that, 1 reactant is copper oxide and that has converted into copper. Another reactant, hydrogen, is there, and this hydrogen is getting converted into H2O. Hydrogen converted into H2O. What you have observed here? Addition of oxygen. No, hydrogen was single in the reactant side, but in the product side this hydrogen, along with the hydrogen who is there? Oxygen. So what is the process you are observing here? Addition of oxygen you are observing. Oxygen got added, so this H2 has converted into H2O. Okay, so addition of oxygen is called what? Oxidation. Yes or no? So this particular conversion is oxidation. Conversion of H2 to H2O is oxidation. Conversion of CuO to Cu is reduction. 1 reaction, 2 processes you have observed. You have observed oxidation also, you have observed reduction also. Such a reaction we will call it as redox reaction. Okay, here they will ask you a question. Which one underwent oxidation? Which one underwent reduction? They will ask. So how do you answer? Who underwent oxidation? Among the reactants you have to select which one underwent oxidation and which one underwent reduction. Okay, So among copper oxide and hydrogen, which one underwent oxidation? You see, hydrogen underwent oxidation. Yes or no? Yes or no? Hydrogen underwent oxidation. Here we are writing H2 converted into H2O, means oxygen is added. Addition of oxygen is oxidation. So what I can write here? H2 underwent oxidation, or H2 undergoes which one? Which process? Oxidation. And among the reactants, which one undergoes reduction? Copper oxide. Not just copper, you have to tell copper oxide undergoes reduction. Copper oxide undergoes reduction. Okay. In other words, we say hydrogen is oxidized. Oxidized means undergoes oxidation. Or copper oxide is reduced. Like that also we can call. Anyway, I will work with more examples in the next video. Is that clear? Thank you so much. Subscribe the channel.